Hi guys, today we're going to look at slope and equations of lines. So I want you to pause the video, take a minute or two, and try the two do now questions, and then come back to the video and check your answers. Alright, so looking at the first do now question, since we're looking for the slope of the line x equals 5, we're really looking for the rise over the run of the line. And looking at that line, we can see that it rises any amount really. You can choose like an amount like 10 or something, but the run is 0. That's because the line does not move horizontally anywhere on the graph. It's a straight up and down vertical line. And what happens when you divide by 0 is you get undefined. So that's why our slope of a vertical line is undefined. Hopefully you remember that from last year. Okay, looking at the second equation from the do now, we had to take an equation of a line and identify its slope and its y-intercept just from the line given. So what we really need to do is take this equation and put it into y equals mx plus b form. So we can move around some of the pieces of the equation. I subtracted 3x from both sides and then divided everything on both sides by -2. And we get y equals 3 over 2x minus 6. Having it in y equals mx plus b form makes it really easy to just pull out that the slope is going to be in the m spot and the y-intercept is going to be in the b spot. So once we've got that, we know that our slope is 3 over 2 and our y-intercept is -6. Okay, so two things that we're going to talk about today are finding the slope of a line, which we've kind of done the last couple of days, and also what slope-intercept form is. So I want you to take a second. We're going to copy down our slope formula into this box. Okay, and as we've talked about, slope formula is the change in y over the change in x. And another way you can write it is y2 minus y1 over x2 minus x1. So basically finding the difference between the y's and dividing that by the difference in the x's. That'll get us our slope. Now, when I asked you to do this on the do now the other day, a lot of people wrote y equals mx plus b, which is actually our slope-intercept form. One is a formula, one is a form, and the difference between that is a form is a way to write an equation. So our equations are linear equations. They all have x's and y's, and slope-intercept form is just one way to express them. It's going to always take a certain form, and things are going to come in a certain order. Slope formula is a way to calculate slope. So slope-intercept form is y equals mx plus b, and as we've talked about, m is our slope, and b is our y-intercept, or where our line crosses the y-axis. Okay, so I want you to take a look at number 1, and it's asking you to plot the points on the graph below and then find the slope by counting the boxes. So using your graph, I want you to count what the slope is, so think rise over run. And then for B, I want you to actually use slope formula. And then for C, you're going to write the equation of the line using what we know about y equals mx plus b. So take a second, pause the video, and then come back and check your answer. Okay, so you should have counted your boxes going up and then to the right, starting from -2, -8, and going up to 3, 7, and found that the rise was 15 and the run was 5. So putting those into a fraction, rise over run, we get 15 over 5, so our slope is 3. So we get that from counting boxes, but we can also use the slope formula. So we did y2 minus y1 on the top, x2 minus x1 on the bottom, get the same exact thing, 15 over 5, and confirm that our slope is 3. Now the last part, we want to write the equation of the line. And we have one piece, we have the slope, but we also need the y-intercept to do this. So looking at your graph, you should be able to see that our line crosses the y-axis at -2. Mine's a little bit off, but hopefully yours is a little neater. That's going to give us what we need to know about the y-intercept. So let's go ahead and start writing our equation of the line. We're going to start with y equals our slope, 3x, and then we want to subtract 2 for the y-intercept. And again, it's a form because it's following this pattern of y equals mx plus b. It'll always go in that order. All right, same idea here. Pause the video for number 2, try it out, and then come back and check your answer. Okay, so by plotting your points and counting the boxes, you should have got a slope of -3/2 after we simplify. The line segment goes down 6 and right 4, and then we can confirm that using the slope formula of a line. Now the tricky part here is writing the equation. We have the slope, but we don't yet have a y-intercept because our line segment that we've drawn doesn't actually hit the y-axis. But we know that this is eventually going to be a line, so we know it's going to extend infinitely in both directions. We also know that the slope is -3/2, which means that the pattern here is that we're always going down 3, right 2, down 3, right 2, and hitting a nice point. If we reverse those directions and instead go up 3 and left 2, we should be able to extend the line going up and to the left. So I'm going to do that. I'm going to go left 2, and up 3, and we've got this point right here. And you'll see that point hits the y-axis very nicely, and that is at 4. So now we've got enough information where we can go ahead and write our equation. Y equals -3/2x plus 4. Okay, so if you flip the page, we're going to take a look at writing out slope-intercept form given different things. So sometimes you might not always just be given the slope and the y-intercept. That would be too easy sometimes. So sometimes you'll be given something else. So at the top here, I've got a couple steps for writing a line in slope-intercept form. The first one is substitute the given point in. So sometimes you'll be given a point, and what's really nice about being given a point is that you automatically get an x and a y, and those will very easily be substituted into the x and the y in the equation. Sometimes you'll be given the slope as well, so you want to substitute that in. And a lot of times you'll have to solve for the y-intercept. You won't know the y-intercept, kind of like we didn't know the y-intercept right off the bat in the last problem. And really what it comes down to is you're just solving for it algebraically, and then at the very end you'll have your y-intercept and your slope to be able to write your equation. So for number 3, we are given a line having a slope of 3 that passes through the point 1,5. Write the equation of this line in slope-intercept form. So we're given a slope and a point, and we know we're going to plug it into y equals mx plus b, so I'm just going to rewrite my equation here. And I have a y value. I've got that 5 from the point, so I'm going to plug that in. I also have a slope. That's that 3. And I've also got an x value, that's the 1. And the only thing here I'm missing is a b. And since I've got an equation with just one single variable in it, it's very easy to solve. Okay, we're going to start solving for b. And we find out that b equals 2. Now I've got enough information to write the equation of my line in slope-intercept form. I've got the slope from the beginning, and now I've got my newly found y-intercept. So that's my equation of my line. So you're not always going to be given just the slope and the y-intercept. Sometimes you might have to find one of those two things. Take a second, try number 4, and then pause the video and come back. Okay, so after working it out and plugging in what you do know about this line, that its slope is -4/3 and that a point it passes through is 3, -7, we're able to calculate the y-intercept as -3 and then plug everything that we need for slope-intercept, specifically the slope and the y-intercept, back into the equation, and we come up with y equals -4/3 x minus 3. Okay, so on that note, we're going to look at another form of a linear equation, basically another way to write a linear equation. And this is going to be called point-slope form. So I'm going to give you the form first, and then we will do a couple examples with it. Point-slope form looks like y minus y1 equals m times x minus x1. Something I want you to pay close attention to, the subtraction signs. Okay. And also the fact that you have a y and an x and a y1 and an x1. Okay, as we go forward, you're going to see that x and y, the ones that don't have any subscript, are never going to change. They're always going to be x and y. x1 and y1 are going to be our points. Okay, so let's take a look at number 2. We want to write a linear equation in point-slope form given the slope and 1 point. All right, so we're given a slope, that's pretty easy, it's m. The point is going to also be called x1 and y1. So now we've got m, we've got x1, we've got y1, we can put it all in, and we can put this all into point-slope form. So the y is going to stay as y. We're going to subtract y1, which is 9, and then we're going to put in the slope, 4/3, and then in parentheses x, that's just a normal variable, and minus 6. And we've got point-slope form. So notice that our x and our y that didn't change at all, those are the ones without the subscript, without the x1 and the y1. Those x1, y1 are where we're going to plug in our point. So let's try another one, looking at number 3. Ooh, it's coming with me. Bring it over. Okay. We've got a slope. We've got a point. We'll label that again, x1, y1, and we want to put it into point-slope form. So again, y is not going to change. We're going to subtract the y value, 6, add in the slope, 2/3, x minus 0. And now we could go a little further with this equation and simplify it because we've got that 0 in there. And we've got y minus 6 equals 2/3 x. Now you can see that red equation is really close to slope-intercept form. We could very easily add 6 to both sides and we would have slope-intercept form. What's nice about point-slope form is that you can very easily see the slope and a point on the line. What's not quite as easy to see is a y-intercept. So the two forms give us different pieces of information. Slope-intercept form tells you the slope and the y-intercept. Point-slope form tells you a point on the line and the slope. So they give us different pieces of information. On that note, we're going to flip the page and do a couple more examples. Okay, on this page I want you to try 4 and 5 on your own, pause the video, and then come back to check your answers. Be careful with the signs of all of your numbers. Okay, if you need to, go back to the page before or copy it down right now. Point-slope form looks like y minus y1 equals m times x minus x1. Pay really close attention to those minus signs and what they might do to your numbers. Okay, so for number 4, when you substitute everything in, you're going to start to see a lot of double negatives. And what we want to do is we want to simplify those double negatives. So we have y minus -3, which turns into y plus 3. And we have x minus -2, which turns into x plus 2. Now, notice I didn't simplify any further. I'm not distributing that -1. I'm not bringing the +3 over to the right side. If we start to distribute or simplify, we're taking it out of point-slope form and we're turning it into slope-intercept form, which this question is really just looking for point-slope form. So it's a way to write the equation, and we want to be specific about how we're writing it. So that's number 4. And then looking over at number 5, again, a double negative showed up. Okay, so it ends up being y plus 1 equals -4 times x minus 5. And it's really interesting to note that because we had those minus signs before, what ends up happening is after you apply the double negatives, we've got a positive 1 now, even though we started with a -1. And we've got a -5 in the equation, even though we started with a positive 5. That'll always happen. You'll always end up having the opposite sign in the equation because of that minus sign. So if something was positive before, it's going to show up in the equation as a minus, and if something was negative before, it's going to show up in the equation as a plus. Okay, so now looking at number 6, we want to write a linear equation given 2 points in point-slope form. So let's think about it. For point-slope form, we need 1 point and the slope, but we're not given that in this question. So we have 2 points, and we want to eventually find slope to fit into this equation. So take a second, pause the video, find the slope between those 2 points, and then use that in your point-slope form. Okay, so after using your 2 points and slope formula that we discussed before, we should be able to find that the slope is -1. So now we've got the slope and we've got 2 points to choose from for point-slope form. Now the nice thing here is that you can't go wrong with either point. So we can either take the first point and substitute it in. Oh, mix that up. Or we can substitute the second point and either one is correct. Because all you need for point-slope form is one point that's on the line, which both of these equations have a point that's on the line, and the slope, and both of these equations have the slope. So you really can't go wrong choosing either one as long as they are points on the line and they were given to you as points on the line. Okay, for number 7, we've got the same exact points as number 6, but we want to now write this equation in slope-intercept form. So we are definitely going to need the slope for this problem, which we got in the last problem, so let's just carry it over. We know that the slope is -1. And now, if we want to write it in slope-intercept form, well, we've got the slope, but we need that y-intercept. In order to find the y-intercept, we can use one of those 2 points that are given to us and plug them in. We've got y equals mx plus b. All right, let's choose a point. I'm going to do 2, 1 because there's no negatives in it. And we're going to substitute them in along with the slope. And then I'm going to simplify and solve for b. And we get b equals 3. And now I've got enough information. I've got my slope and I've got an intercept to be able to write my equation. So I now know that I can write y equals -1x plus 3, which is exactly the same line as the other two that we got in number 6. It's just in a different form. Like if we were to simplify both of these equations, we would get y equals -1x plus 3. Okay, they're both different forms of the same exact lines equation. Okay, so from here on out, I want you to try the practice problems, numbers 8 through 11, and then you can come back to the video. I'll put the answers up, and then once you finish that, you can grab your homework and get started on it.